Right. Good evening, everyone. Myself, Servan Kumar, IES 2010 batch. Welcome to ESE Engineering Academy. Today, we will be seeing how to prepare communication system, especially for GATE examination in 2024. Okay. So, let us see what is the syllabus that is there, how you have to prepare, and how many marks you can expect from each topic, and overall, what should be the preparation strategy. So let us straight away go into that. So if you refer the syllabus for GATE examination, it is conducted by ISC Bangalore this time, and they have clearly given the syllabus, and our communication systems comes under section 7. So the overall weightage that you have in communication systems, if you see, it is somewhere around 12 to 15 marks. The total weightage for this subject will be 12 to 15 marks. So be very prepared for this subject. It is definitely having a minimum weightage of 10%. Okay? So don't neglect this subject, very, very important subject. So let us go through the syllabus first. So under this communications, under this section 7, this is the total syllabus that you have here. Now, don't simply look into the syllabus. I can read point by point. That is not important for us. What is very important for us is how you plan your subject. Okay, now I will divide this into smaller parts first. Let us assume I am taking a analog communication as the first part. Okay, next. Let me change the color. Then let us consider these random variables and random processes as the second part. Okay, then digital communication as the third part. So I have divided analog communication, then I have gone for random processes, and then the digital communication part. All the remaining topics that I have, information theory, fundamentals of error correction, let me put into fourth part. So to be elaborative, let us consider we are having some 4 chapters. So first chapter is analog communication, second chapter is random processes, third chapter is digital communication, and the fourth chapter is the remaining part, means the information theory part and your error correction and coding part. Right. Now, let us see one by one. So if you take the analog communication part, so the total analog communication, the first part of our syllabus, you can subdivide them into these chapters. So this is the best way of your preparation. Never look the total syllabus, it becomes very, very difficult. First you divide the total syllabus, let us say, into modules. So like we have divided into 4 modules. And each module you try to divide into smaller subtopics or subchapters. So if you take the analog communication part, that is one module for us. So I have divided that into 5 small chapters. See here. First is introduction to signals and systems. Why I kept that? Anything that you learn in analog communication is an extension of signals only. So you need to know the basics of your Fourier transforms. What is a signal? What is its transformation? Minimum fundamental knowledge about signals and systems is must. At least up to Fourier transforms you should have very good grip. Then only start preparing for communications. Straight away don't jump immediately onto analog communication part, because you will feel very, very difficult, and that too for GATE examination, everything is numerical. So don't try to do that. Okay, so what you are preparing in this introduction to signals and systems, let me write here, you are doing a preparation of continuous time Fourier transforms. Okay, so what are your basic signals? What are their fundamental Fourier transforms? No need to go into very much depth. Fundamental parts you need to know. And little bit about continuous time Fourier series. This is also important for us. Wherever we require, we will use that part. So in the transformation topic, you will refer to standard signals and systems. And in the Fourier series, you will refer to how you are referring a periodic signal by using Fourier series representation. It can be a trigonometric Fourier series, or it can be an exponential Fourier series. So these are fundamental things that you need to know. Apart from this, you need to know what is sampling process. and sampling theorem. So everything related with sampling. So what is sampling process telling you, and what about sampling theorem? What are the conditions involved in that? So this part is your first chapter of analog communication module. So this will be under your signals and systems syllabus, but this has to be covered before starting your analog communication part. Okay, now once you are done with this, now the next is standard amplitude modulation schemes. So we will start with amplitude modulation schemes. So what are the different type of amplitude modulation schemes you are having? So what we have standard amplitude modulation. We have double sideband suppressed carrier modulation. We have single sideband suppressed carrier modulation. These are all coming under your standard amplitude modulation schemes, and along with this you are also having concept of frequency division multiplexing. So these are the areas that you need to concentrate. So whenever you refer to these points, what are the points that you need to concentrate? So you have to refer to what is a modulated signal expression, S of t, what is the spectrum representation for these modulated signals. So how are we referring to the spectrum, and what are the power calculations, what are bandwidth calculations, and what about modulation efficiency. So these are all the points that you need to understand whenever you are referring to these modulation schemes. Any numerical coming in your exam will be straight away on these things only. There is nothing apart from this that he can ask. And along with this, we will also concentrate on different modulators and demodulators. So that will complete your first chapter of analog communication part. Right? Now, coming to the next chapter, sideband modulation schemes. So when you refer to sideband modulation schemes, what do you mean by sideband modulation schemes? They cover double sideband suppressed carrier as well as single sideband suppressed carrier. So that I have already noted it. So this is the next part. Okay. Now, once we complete these amplitude modulation schemes, then we will have angle modulation schemes. So what do you mean by angle modulation schemes? You will have frequency modulation and phase modulation. These are two modulation schemes coming under angle modulation schemes. So whatever the disadvantages we are facing in terms of amplitude modulation schemes, we will overcome in angle modulation schemes. Again the same points. What is your modulated signal expression, spectrum, power, bandwidth, modulation efficiency. Along with this, what are the different modulators and demodulators. So these are the points that we are going to cover under these angle modulation schemes. Okay, so this is our next part. Done. Now the last part is radio receivers. So what is a meaning of a receiver? Parameters of receiver like sensitivity, selectivity and fidelity, and types of receivers. Tuned radio frequency receiver and a super heterodyne receiver. So these are the things that we are going to cover. So this includes your TRF receiver, and the next one is a super heterodyne receiver. So these are the two receivers that we are going to cover. And whenever you cover these receivers, we have to concentrate on intermediate frequency, tuned station frequency, what is IF, what is FS, and what is image frequency. So these are the areas that we have to concentrate. So this clubbed together will be your total radio receivers part. So when you complete all these 5 things, then the total analog communication part is completed. So this is how you have to break up each module into separate chapters. Then it becomes easier for you to understand and concentrate on the subject. Otherwise, what happens is you will keep on doing preparation, it will never end, and you don't know when to stop also. And time management is also very important. So whenever you are starting one topic, let us say you have started your standard AM schemes, don't go more than 8 to 10 hours, max, that is enough. First is first, means you write down all the equations, whatever the theory part that is required, what are the formulas that are there, numericals that are there. Try to do point by point, but in a time bound manner. That helps you a lot in covering all your points in your syllabus. Now, coming to the weightage, that is also very important for us. Here, you can expect the total analog communication part, generally the weightage will be around 2 marks to 3 marks. So here 2 or 3. Maximum weightage for this topic is around 3 marks. Either 2 or 3 marks is the total weightage that is given to this particular area. So based on that weightage also, you need to spend your time. Don't unnecessarily spend time on less weightage topics. That is not going to help you. Smart preparation is also very much required. So try to focus on this particular logic. Okay. So this is the first part of our module, the analog communication part. Now let us see the next part. So the next part I have taken is the concept of random variables and random processes. Very, very important area and area where you have to focus a lot. Okay. And most crucial area also. It is not so simple. You have to concentrate more on this particular area. So if you refer to this random variables and random process, this entire module that you have here, I have divided this into 6 subtopics, or you can say as 6 chapters. First one is single random variable. So here, when you refer to a single random variable, means what? You have a random variable x. So I am talking only about one random variable x. So what are the different things you will have here? You will have its a probability density function, and you will have its a probability distribution function. Okay. And what are the statistical parameters we will have? You will have mean value, mu, you will have mean square value, and you will have variance, and you will have standard deviation. So these are all the parameters that you need to understand, that whenever you have a random variable, you have to go with this part. Okay. Is it clear? Right. Sorry for the interruption. There is a small technical glitch, so I have to stop here. Let us proceed. Okay. So when you take a single random variable case, so these are all the things that we are calculating based on a single random variable concept. So what is a random variable? Density, distribution, calculation of mean, mean square value, variance and standard deviation. Now, once we are done with this, then we are going for multiple random variables case. So multiple random variable means what? Instead of taking a single random variable, you will go with two random variables. So two random variables means we are taking x and y. So here you will have joint density function and you will have joint distribution function. Two parameters will come. Along with this, you will have some very important and interesting parameters as correlation between two random variables, covariance between two random variables, and correlation coefficient between two random variables. So when you refer to a single random variable, these are our statistical parameters. So these are our statistical parameters when I refer to a single random variable case. But when you go for multiple random variables, these are the things that you need to get it. Now if you observe carefully, these are not actually specified in your syllabus, but without knowing these things, you cannot understand anything. That is the reason first two parts of your communication part coming under random variables and random processes, you need to understand these concepts. Okay, so here we will use three words very frequently. One is independent random variables. We also call it as IRVs. Okay, and uncorrelated random variables and orthogonal random variables. So all these three are very important for us. So what is the meaning of these 3 points? Because whenever a question is framed under this topic, there cannot be a question framed without these things. So very clearly you need to understand the concept of these 3 points. So all these things will be very clear in the first 2 chapters under this particular module. Okay, once we are done with this, then you will have your standard distributions. So standard distributions are predefined distributions. So what do we have in that? We are having uniform, we are having Gaussian, we are having Rayleigh, we are having binomial, and also we have Poisson distribution. So these are different standard distributions that you can apply on your numericals. So whenever a question is framed, they will definitely use these standard distributions. So these are the areas that you need to focus on. So the complete syllabus under random variables and random processes, this is a core fundamental area. So these first 3 chapters under this module is very important for you. So whatever the standard textbooks you refer or our material that you refer, whatever it might be, this is the core area of your focus. So don't lose focus on these points. This is very important. Now once we are done with this, then your actual syllabus starts. So what is your actual syllabus? If you just go back to our random process, see the syllabus that is given here, how they have started this. Autocorrelation and power spectral density, what are the properties of white noise, and filtering of random signals through LTI systems. So this is our actual syllabus, which is coming under module 2 of your communication part. Now this part actually starts from here. So to understand this area, you need to focus on these 3 points. Without understanding these 3 things, you cannot understand any part. I hope this point is very clear for you. Okay, now what you are going to study in this? So when you refer to random process, let me take one more page, just a moment. Just a moment. Yeah. Let me just take one more page to explain that. Okay. So when you refer to this random processes part. So what do you mean by a random process? So we will start our discussion with a random process. Okay, so whenever you take a random process x of t, it is a function of time which will have a random variable. So under this random process, most of the times we will be concentrating on wide sense stationary random processes. So what is the meaning and why we consider them as stationary random process? So under this, what are the different examples you have and how to concentrate that area? That is what we are going to discuss here. So this comes under the category of wide sense stationary random processes. So whenever you have a random process x of t, we will have an autocorrelation function for this random process, for which when you apply Fourier transform, we will have its power spectral density. So I hope points are very clear. I am just elaborating how you have to study. I am not going into formulas or any technical areas. I am just concentrating on the areas that you need to concentrate. So what is autocorrelation function, especially coming under the category of wide sense stationary random process, and then how will you identify its power spectral density? So these are the areas that you need to focus. Okay. Now once you are done with this, see the syllabus here. Random processes, then random processes and linear systems. That is the second part. Means what? You have a random process with you. So I have a random process with me. I am considering a system now. So it will generate its output. Okay. Now see here. So when you have a random process x of t, it will have autocorrelation function and it will have power spectral density. Done. Now what is the type of system we will be considering? Our syllabus deals only with linear systems. So any linear system will have some impulse response for which you will have its transfer function. Now how will your system respond to this random process? That means there will be an output random process y of t generated, for which you will have its own autocorrelation function and you will have its own power spectral density. So what are the relations that you develop from this side to that side? Only on this area, every year 1 2 marks question is coming. Only on this area. I am not talking all the other things. Only on this concept. How a linear system reacts to a wide sense stationary random process. Just a few equations, 3 or 4 formulas, that's it. Definite 2 marks question from this year. Mark it. Next year also the same thing is going to happen. And questions are rotating only on some standard functions. They will not go in depth also. I already told you some basic signals, some basic systems, transformations you need to know. The first part, signals and systems. Only using that he is framing these questions. So you need not do too much of hard work also. A little bit smart work in this particular area will give you 2 marks. That is how you have to prepare. That is the reason I have split all these topics into small parts, so that whenever you do your preparation, you will understand clearly where you have to concentrate. So this is your random processes part and response of random processes to a linear system. Done? Now, the last part is noise analysis of analog communication system. Actually, this should come under your analog communication syllabus, but without understanding the concept of noise, you cannot do anything. That is the reason you have to keep this topic in this area. So what you will do in this area, just let us go through this thing. So basically once you understand this part, let me take one more slide. Yeah. So all these random processes we are considering and we are building up noise random process, N of T. So what is channel noise, how it behaves, especially free space channels, and we deal something related with additive weight Gaussian noise. That means what you are doing, you are now considering a system where your x of t is N of T. So it will have its own autocorrelation function, it will have its own power spectral density. Done. Now at your receiver, all these points I am talking at the receiver side. What is going to happen? You will get your noise which is taking this form along with the signal. Which signal? Your modulated signal. Correct or not? Analog communication means either amplitude modulated signals or angle modulated signals. One of the signal will be there. Along with this, noise will get added. What is the nature of the noise? Because you are using free space channel, it should be additive weight Gaussian noise. Now this is going to come at the input of your receiver. Now you will have your entire receiver block. So this total block I am considering as receiver. So it can be any type of receiver. Common receiver we use is a synchronous detector. Let's assume. Now at the output of your receiver, so this is your receiver input, you have your noise and you have your signal. Output of the receiver, you will have again signal component and noise component. Correct or not? Because both are getting processed. Na? So you will get both the components at the output. You will have the signal component part as well as the noise component part. Now what we do here is we calculate signal to noise ratio at the input of the standard baseband receiver, and you also calculate signal to noise ratio at the output of the receiver. So all these calculations we are doing at the receiver side only. What we measure here is the ratio, signal to noise ratio at the output to signal to noise ratio at the input of baseband receiver. This is what we refer to figure of merit. So why this is required? Because you are studying so many modulation schemes. In amplitude modulation only, we have standard AM, we have DSB, we have SSB. And in angle modulation schemes, we are having FM and PM. So totally you are having 5 different modulation schemes. But noise is same or not? Because you will not have different channels for different schemes. Na? All modulated signals, you will transmit to the same channel. Free space channel means air is the medium of transmission. So when these signals goes into the channel, how your channel reacts to these modulated signals in presence of noise. So that calculation only we are referring as figure of merit. So some modulation schemes may behave better way in noise, some may behave much worse in noise. So the value of figure of merit will tell which modulation scheme is better in presence of noise. If noise is not there means that's an ideal case, but that is only for study purpose. You cannot do that. Practically you will have noise in the channel. So whenever there is noise in your channel, how your modulated signal is behaving in presence of noise. So that calculation you will get by using figure of merit. So if you want to understand FOM values, you have to understand noise random process. Otherwise there is no way. That is the reason why we are studying this random processes concept. Once you get this, then you will have your figure of merit values. Now you will have a comparison technique. Which modulation scheme is better and how it is behaving in a better way in presence of noise. So that calculation comes under your figure of merit. So that is the reason this part is the core of your entire communication system. Maybe that is the reason why IITs also have kept this syllabus at the starting point. They did not start with analog communication, they started with random processes. So even in your engineering curriculum also, most of the universities, random variables and random processes is introduced in second year first semester. First you will study that. Later on, by the time you come to second year second semester, or in some universities third year first semester, you will be introduced with the modulation schemes. It can be analog or it can be digital. So without understanding this random process concept, you will never understand noise. That is the reason I have split this into clearly 6 different topics or chapters. Understand the first 3 chapters for getting fundamentals, and then these last 3 chapters are actually your syllabus. Now, if you refer to the weightage that is coming in last 3 to 4 years, on an average, you are getting around 4 marks, which is very, very good weightage. One 2 marks question 100% pakka, and 2 1 mark bits, or sometimes 2 2 marks questions are also coming. So as far as I am concerned, first priority give it to signals and systems introductory part. Without knowing that, you cannot do anything. Complete analog modulation. So some part of your communication syllabus is done. Then you come to this random variables and random processes. Don't leave anything in this area. Very, very, very crucial. Even if you go into your higher studies, MTech programs in IITs or NITs, where your master's program is in communication background, definitely this topic is going to help you a lot. Okay, that is the importance of this particular topic. I hope all the points are clear. Okay, so individually, what are the things you have to study, how you have to plan, that also I am giving a very good clarity. That is the reason heading itself is preparation strategy. Okay, right. So these are the areas you need to focus. Now, once we are done with this, let us come to the next module. So we have covered analog communication part, and we have covered random variables and random process part. 2 modules are done. Let us come to the digital communication part. So whatever you are seeing here is a part of digital communication, or I should say digital communication systems. So this also I have divided into small parts, or you can say it as chapters. So what are the different areas that are there here? So if you refer to the baseband data transmission, very simple, if you think some words are complex or complicated, try to refer definition of that particular part. Sometimes dictionary also will give you a very good meaning. Baseband means physical channel, that's all, very simple. That means whenever you are doing a transmission of data, your digital data, you are doing a transmission on a physical channel. Physical channel means what? It can be an optical fiber cable, it can be a twisted pair cable, any copper cable. That means there is a physical medium of transmission between your transmitter and a receiver. That is what we refer to as baseband. So that's the first part of our digital communication system. In that, what you have, you are having pulse code modulation. That means coming under pulse digital modulation schemes, inter-symbol interference, differential pulse code modulation, and delta modulation. That's all. Now, this topic is simplest of all, easiest of all. Why? Formula based questions. There is nothing special that any examiner can ask here. Strictly formula based, and the maximum weightage that you can get on this topic is 2 marks, not more than that. It can be a 1 2 marks question, or it can be 2 1 mark question. So basically, why this is easy? Whatever the things you study under pulse code modulation, if you refer a PCM system, what parameters we have here? We are having quantization error, quantization noise power, signal to quantization noise power. That's all. Bit rate and bandwidth. That's all. Then, just based on these 5 things, questions will be framed. So all are formula based only. If you refer syllabus and study, very, very straightforward questions. That's the reason most of the times bitrate bandwidth related questions, 1 mark bits, comes on this area. And once you are done with this, then we will have differential pulse code modulation. It is an extension of your PCM system only. There is no numerical on that. But why we have to study? To understand delta modulation. Most of the times we pronounce this as adaptive delta, linear delta modulation, not A, it is L. Just a moment. It's called as a linear delta modulator. Okay. Now, whenever you refer to this delta modulator, again the same thing. What is the quantization noise power? What is the signal to quantization noise ratio? And you will have slope overload distortion conditions and granular noise conditions. Finish. See the beauty of this topic. Very limited syllabus, formula based, easiest way of getting the marks. So that is the reason I tell you, whenever you split the syllabus in this way, it becomes very easy for you to concentrate. Very limited. Notes also, when you prepare, you make a list of the formulas wherever they are coming. Refer to those formulas, that is enough. This topic, not only forget any other competitive exam like DRDO, ISRO or any other technical exams, 60 to 70% of questions coming from digital communication will come from this area because formula based. Generally, other than GATE exams, whenever you write, they are 1 minute one question. So you cannot think so much and do some numerical there. It is simply formula based. So this type of topics are more important for such examinations. Okay, right. So this is the area that you need to focus on. Now, once we are done with this, the next part of digital communication, this also comes under digital communication only. Your total digital communications is two parts. One is baseband and another is band pass. So whenever you refer to band pass, simple meaning as I told you earlier, baseband means physical channel. Band pass means channel is free space. Finish. That means air is a medium of transmission. So whatever the binary data you are getting, you are again converting them into carrier, because you cannot simply throw binary data into air. You have to convert that into continuous format and then transmit onto a air, or medium of transmission is free space. So that is what happens in this band pass data transmission schemes. Now, this is very complex topic. Baseband, the easy one, band pass is the toughest one. So why it is like that? Because the way you understand the subject, there are no strict formulas. Baseband, why it is simple? Direct formulas. You need not do anything. Substitute parameters, you will get answers. Band pass is not like that. Understand the concept, apply the concept, every question will be different. That means today you have some question with you. Tomorrow the same question might be there, can be asked completely in a different manner. That is the reason, without understanding the concept, you cannot crack questions on this area. Surprisingly, more weightage is for this area. You will get almost around 3 marks to 4 marks. One definite 2 marks question is coming from this area. So again I have split this into subtopics or chapters. First is a different binary MRA modulation schemes. That means you will study here binary amplitude shift keying, binary phase shift keying, binary frequency shift keying. These are called as fundamental modulation schemes. Okay, so in all these modulation schemes, you will see what is the structure of modulator, what is a constellation plot, how you are drawing a constellation plot, then how are you calculating the probability of error. These are the areas of our focus. Along with this, what are the bit rates and what are the bandwidths. Finish. So most of the times, the question coming from this area will be a 1 mark bit. Easy one. Now, the second part of this is MRA PSK schemes and MRA QAM schemes. Means these comes under higher order modulation schemes. Why we are going for a higher order modulation scheme? That too especially for PSK and QAM. and what are the benefits you have, what are the advantages you have. So these two modulation schemes, questions framed will be mostly on constellation plots. And comparison of probability of error based on minimum distance that you are getting on the constellation plot. So these will be the primary areas of your focus. So try to understand these points. Okay, whenever a question comes on constellation plot, it is definitely a 2 marks bit. There is no chance of asking for 1 mark. So that is the reason whenever you refer to these constellation plots, again different models will be there. Mostly you will be referring to rectangular plots, circular plots. So these are the areas of focus whenever you do comparison of constellation plots. That is the reason weightage is also more here. If it comes 2 marks, continuously 2-3 years we got questions on constellation plots. From the last 2-3 years we are not getting. So this year you can definitely expect a question on this area, especially if you take ISC Bangalore. They are very good at maths. So when they are good at maths, everything is related with maths. So chances of getting good questions on this area is very, very there. Okay, right. I am not saying 100% probability, there is a chance. Okay. Now, let me take one more page. Just a moment. Yeah. Now, the next part of our syllabus, if we see, this is done. Optimum reception of a digital signal, very, very, very important topic. So whenever you come to this part, so basically what we do here is, we will study about the receiver. So something goes at the input of the receiver. There is something called as a threshold detector. This is the symbol we use. Then output of the threshold detector will develop your binary bit sequence BK. I am just taking a general statement, that's all. So what is the meaning of that optimum receiver? The same you have to understand first, then you can study. So basically what we do here is, there is a chance of error coming at the output. That means what? There is every chance that bit 1 may become 0 or bit 0 may become bit 1. That means there is every chance of probability of error here. Now our target is to maintain this probability of error as minimum as possible. That is a target. So when you want to minimize the probability of error, the threshold voltage that you are setting here should be optimized. This is what we refer to as optimum value of threshold voltage. So this block which I am showing here is called as threshold detector. So whenever you take this threshold detector, you have to see that the threshold voltage is optimized. How you can optimize? There should be some logic. That logic is using MAP algorithm. Okay, some cases we will also use ML algorithm. Maximize a posteriori and maximum likelihood algorithms. These two algorithms will help you to optimize the value of the threshold voltage used at the threshold detector side. So that will reduce your probability of error. Sometimes it will be minimized, sometimes it will be in limits. So these two algorithms are very, very, very important, and surprisingly very important 2 mark question comes on this area. Clear? Sorry. So this is the area that you have to focus. Now, the last part is optimum reception of both baseband and bandpass data transmission schemes. That means you are actually designing a receiver. So what are the different receiver structures we have here? we are having two types of receivers. First one is a matched filter receiver, and the second one is correlation receiver. So these two receivers are optimum receivers. We are not calling as simple receivers. We are calling them as optimum receivers. That means what? We are setting a threshold voltage which will automatically make your probability of error to become minimum. So this is also one very, very important topic. And this also has, anytime question comes, it will be definitely 2 marks. So lot of 2-mark question possibilities are there from this topic. One is from the constellation plot, another is from MAP ML decoding schemes, and another is from this matched filter receiver and correlation receiver. So very good questions are from this area. That is the reason I told this is the most complex topic, and definitely the weightage is 3 to 4 marks. That means you can definitely expect 2 marks questions. One topic they may skip completely, like matched filters and correlation receivers. Sometimes it may come, may not come. Constellation plots also, continuously they asked for 2-3 years, then they stopped. So like that it may repeat, but MAP ML based decoding schemes, every year question is coming. So that is the reason this is little bit complicated area, but sure short questions, weightage is more. So don't leave this topic, very, very, very important topic. So this is how you have to cover the digital communication part. First part is baseband, next part is bandpass. Now, once this is done, the remaining part is very simple, information theory and coding. You need not spend more time on this area. Actually, this is 2 subjects in your engineering curriculum, but in GATE syllabus point of view, it is very, very much limited. So don't waste too much of time on this area. Maximum weightage is 1 mark to 2 marks, not more than that. So here also you are having information theory and coding part. So information theory and coding part covers entropy, types of entropy, and different types of channels we have, channel coding theorem, and what are the different types of coding schemes that you have. This part will be covered under this area. Okay, so fundamental things only. I am not going in depth in any of these topics. Don't waste too much of time. It should be a time bounded manner of preparation. What is information? What is entropy? What is channel capacity theorem? And different types of channel coding techniques. Like we are having linear block quotes and cyclic redundancy check. Only those, very much restricted, and very limited time you have to spend here. So this completes the total syllabus that is there in your communication systems. Now, let us just revisit that page of your syllabus. Then you will understand how to study that overall. Just I will go to that first page. Yeah, now you see the syllabus and see how we have given the preference. First preference we have given to analog communication part. Okay, so all this part, first to understand signals and systems is must. Fundamentals of signals and their transformations. Fourier series, its representation. Then concept of sampling and sampling theorem, that is enough. Once you complete this, then the second preference we have given to random variables and random processes. From the very fundamental to the last part, don't miss any of this area. Okay, and then the third preference we have given to digital communication part. So here you are having baseband and band pass, PCM delta modulation, then all the fundamental binary modulation schemes, MLA schemes, constellation plots, receiver structures, optimum receivers, use of MAP and ML decoding schemes. They are very clearly mentioned here. See here, PCM, DPCM means baseband, then band pass, ASK, PSK, FSK, QAM, finish. And then what are the things that you need to refer in that? What is inter-symbol interference? Bitrate bandwidth requirements. And then see this line, MAP, ML. Very, very, very important aspects. Definite 2 marks question from that area. And then matched filter receivers, bit error rate calculations, done. And then the last part we have referred is this information theory and coding part. What is entropy, what is information, types of entropies, types of channels, channel capacity theorem, and then error correction and detection coding schemes like block codes and cyclic redundancy check. So this is how you have to split your total syllabus, have a strategy in every aspect, and then proceed further. So totally we have divided into 4 parts or 4 modules. Each module is having its individual chapters. So if you subdivide like this and study, then it becomes very easy for you to crack the exam. Not only in my communication system, in any subject you refer, this is the only way of doing very good preparation. Now, whenever you do this, your preparation should be time bounded. Sir, whatever you told is very good, but I have spent 3 to 4 months on this subject. Then you will not even qualify for the exam. You might become master of communications, but you are not having enough time to complete the total syllabus. Already we are into first week of September. So maximum you have to complete your syllabus at least by December. Don't go after December. January month should be your total preparation. I mean the revision strategy, that's all. Don't do anything new in January. So how many subjects you want to prepare, it is up to you. But at least 5 to 6 subjects total preparation is sufficient for ECE branch. You can easily crack a rank less than 500 if you have a total grip on 5 to 6 subjects. Okay, so this is the total syllabus that is given to you and how you have to do your preparation by splitting into smaller areas. So clearly I have given here, intentionally I have written it so that you will understand what I am actually telling. If I just go through the slides, then it's a normal scenario. I just want to make it a little more interesting and practical. So that's the reason I have taken in this fashion. Okay, it's a very good way of doing your preparation. I am following the same in the institute and organization also. Even the online classes which I take, I will take in the same fashion. So that students also will not get bored. They will have a focused understanding and we will spend almost say 75 to 85 hours for the total syllabus. So even if you do your own preparation, it should not go above 100 hours. So on an average, even if you take 3 hours a day, a strong preparation, it should not go above a month. Maximum 1 month should be the preparation time for this particular subject. Don't go above that. Okay, right. So apart from this, these are the things that you need to focus at every stage. So I have just mentioned the points. You can just go through that. So what you have to do in this every chapter that I have mentioned, every chapter of preparation should cover theory part. So relatively what is the important points. Don't make notes copy paste. You are having some textbooks with you or material with you or some running notes, anything that you might have. Don't just simply copy and paste. Whatever is required, only that you refer. Okay, then derivations wherever they are required, like signal to quantization noise ratio derivation, quantization noise power derivation. These things you have to work out once, then only you will get a grip. So those points. Then standard important formulas, you have to list out them. Whatever important formulas are there, list topic wise, chapter wise, keep them ready. And then worked out examples. You can refer to any standard textbooks. Some minimum worked out examples will be there. Focus on that area. And then finally, previous gate questions. You can refer to last 5-year papers. That is sufficient. No need to go more than that. 5-year question papers are sufficient enough for you. That will be enough for your total preparation strategy. Okay? Now, so these are the things that you have to note it out. Understand the fundamentals. That is the first part. Practice more numericals in previous papers. And then time management. So whatever you do, it should be in a month. That's the reason I told you. It should be around 80 to 100 hours. So even if you prepare 3 to 4 hours a day, it should not go above a month. Maximum 1 month. Not more than that. It should not go strict time calculation. So keep that point in mind, because whatever the things you do, if you cannot manage your time, there is no use. So that is the reason time management is also must. And weightage for this subject is 12 to 13 marks. So quite a heavy weightage. 12% of total gate paper means good weightage. So spending 1 month is good, but not more than that. Okay, and these are the must-do activities. Make note of important formulas, remember standard values, refer papers. That is sufficient. And if at all you want to refer any textbooks for your self-preparation, these are the books that you can refer to. First one is Communication System Engineering, Process and LAE. This is very good for digital communication. Sometimes the same questions as it is are coming in your exams. Okay, and then Top Shilling and Saha, this is also for digital communication. And last one is Communication System by Simon Hackins. It's for analog communication. So these are the books that you need to refer when you study on your own. Okay, so just see the worked out examples, and at the end of the chapter, at least first 10 questions you do. That is sufficient. Don't waste your time in doing the entire chapter problems. Okay, so that is enough, and time is very important. Strictly 1 month strategy, that is sufficient. So these are the things from my side, and I wish you all a very good luck. We will meet once again on Monday, same time, 7 to 8. I will take some standard questions, whatever the chapters I have told you. I will try to cover at least 1 or 2 questions from important chapters. I will discuss them. You will also have an understanding on that particular area. So let's meet once again on Monday at 7 o'clock. Thank you.